Good morning everyone. In this video we will see what is voltage division rule, current division rule and source transformation. First we will see voltage division rule. So voltage division rule is applicable for series circuit. Series circuit means the connection of component in such a way the same current will flow through all the components. So for example, if you are trying to connect a resistance in series, then the end of first resistance should be connected with the starting point of the second resistance. Similarly, the end point of second resistance should be connected with the starting point of the third resistance. So this is called series connection. So in series connection, the current flowing through all the elements will be equal. And also in series connection, the sum of voltages across each element is equal to the voltage across the whole network. So this is called as division of voltage or voltage division. Also, the voltage drop varies directly with its resistance. So for example, we will take three resistors are connected in series combination. Then obviously the total resistance will be sum of all the three resistances. That is R1 is equal to R1 plus R2 plus R3. So according to voltage division rule, the various voltage drops are, so V1, which is the voltage drop across R1, will be equal to V into R1 by R. So here the V is nothing but total voltage in the whole network, and R1 is the respective resistance on which we are going to calculate the voltage drop, and this R is a total resistance of the circuit. So this will give you the resistance of a particular voltage of a particular resistance. Similarly, if we want to calculate voltage drop across R2 resistance, the formula will be V2 is equal to V into R2 by R. So the voltage is equal to, voltage in a resistance is equal to total voltage of whole network multiplied by the respective resistance divided by total resistance of the network. So this is called voltage division rule. So the current in the total network, total current I is equal to total voltage V divided by total resistance, sum of resistances R1 plus R2 plus R3. So similarly we can calculate power also. R1, power in R1 is equal to I square R1, power in R2 is equal to I square R2, power in R3 is equal to I square R3, total power I square into R1 plus R2 plus R3. So substituting the value of I in the above equation, we get total power is equal to V square divided by R1 plus R2 plus R3. So this is how voltage division rule is applied. Coming to current division rule. The current division rule is applicable for parallel combination of a circuit. See, look at the figure. Here R1 and R2 resistance are connected in parallel. Voltage V is connected across this parallel combination. Now voltage drop across R1 is also V, voltage drop across R2 is also V. The current flowing through the R1 is I1 and R2 is I2. So in parallel combination, the voltage across each element is equal, but the current flowing through the element is different. It is differs according to the resistance value of the particular device. So using Ohm's law, we can write what is I1 and what is I2. So I1 is equal to voltage across R1V divided by R1. Similarly, I2 is equal to voltage across R2. It is V divided by R2. So now if we calculate a ratio, I1 by I2 is equal to R2 by I1. The total current in the circuit I is equal to I1 plus I2 and I2 is equal to I1 minus I1. So if we substitute in this ratio, we will get finally I1 is equal to I into R2 by R1 plus R2. So in current division rule, we can calculate the current flowing through the each element. So current flowing one element is equal to total current of the network into R2, it is the opposite resistance divided by sum of resistance. So this is the formula for calculating current flowing through a particular resistance in case of application of current division rule. So similarly for I2, I2 is equal to I R1 divided by R1 plus R2. So this is how current division rule is applied. Thank you.